Okay, ladies and gentlemen, this is our final session for this morning. And I'd like to introduce you to Asli. Asli's an award-winning graduate working in Geolytics. Geolytics are one of our gold sponsors. Yay, well done, Geolytics. Thank you very much. We do appreciate it. Asli's going to present to you her final year project, where she's done a whole load of work looking at social media, sentiment analysis, and other data to understand and identify leisure hubs. Over to you, Asli.
Hello everyone, my name is Asli and I'm a computer science graduate from Greenwich, and I'm currently working as a client solutions developer at Geolytics. So today I'll be presenting my project, which is called Urban Computing and Planning, utilizing Geotagged social media data for identifying leisure hubs, which was published in an IIT conference last year and was also awarded as the second place in SLA Student Awards. So I would like to explain why Geotagged social media data and the importance of it. So especially my generation, Generation Gen Z, we basically live our lives in social media, not gonna lie. And this is how we connect with each other. This is how we share our voices. And sometimes this is how we learn the news from. I thought, as you might not realize all the time, but by using social media, we're posting maybe every day or in every few weeks, and we post stories, we post reviews, we post, photos, but all of those posts actually leaves the digital footprint behind us, and that's a vast amount of data that is just hanging around there. And I thought that what if those digital footprints are not just a noise, but a data we can learn from and maybe use it in an impactful way. So I'm thinking that by using machine learning and some mapping tools, we can actually learn some patterns from this data. And today I will try to guide you through how we can use this data and what's the potentials of it. Let me take a few moments to share where this idea came to me in the first place. I'm Turkish, and a few years ago, 2 years ago, a major earthquake happened in Turkey, and we lost 55,000 people, and we lost 300,000 buildings were destroyed. So it was devastating, and it affected 3 major cities. I could say that basically all those cities were flattened, because as you can imagine, 300,000 buildings is not just a small amount of number. So as you can see it from the map, the Turkey map, these are the fault lines that we have, and it's crossing all over the country. And so there is nothing that we can do about it, as it is a natural disaster. We can't prevent it from happening. And this is the major natural disaster that always happens in Turkey, and it will happen in the near future, I guess. We will never know, but we're expecting one in Istanbul as well. So this is a problem for my country, but other countries have different problems because of their geography. So maybe another country has a flood problem, another one has a hurricane, and another one could cause like wildfires. So this will keep happening because it's a natural disaster. But what we can do is, maybe after it happens, we might try to able to find people and somehow help them in a faster way. So when the earthquake first happened, what I did was, I was living in London and I was far away, and I tried to find how big it was by using, of course, I think like everyone else, searching it from the Google, and I couldn't find anything on the new channels yet. So After that, when I looked at other social media platforms like X or Instagram, there were lots of posts already. People were posting about where they were, what they needed, and which roads was closed, and all those sort of stuff was already out there in social media. So I thought by using those social media geotagged posts, we might be able to locate people and we might be able to help them. So that's where the idea came from to me in the first place. So how we can achieve this, maybe by building a system in real time. So I thought maybe we will collect the geotagged social media posts in real time and guide for resource allocation in an efficient way. But for this, we won't have time to clean the data because it's going to be in the real time. So we need some system that it will understand right away, and maybe by using machine learning and some models so that it will extract those texts and understand it in some way. And after that, we will need the live crisis mapping. So that's the ultimate goal, which will create a mapping system that it will show those geotagged posts in with their location exactly, maybe on the map itself, and then we can see what's happening on the ground exactly and where it is happening. But there are some challenges in the implementation, of course. As you'll understand, the data will come in an unstructured way, in a really messy way, and then we won't have any time to understand this data or filter this data because it's not a data set that we can work on weeks or clear it out and all sort of stuff. It needs to happen at that moment when we get the data. So that's the most challenging part. But other challenge is, I would like to say, the accuracy. Because you might build a model that maybe your model is 90% accurate or 95, even 98. And you will say that, yeah, this is enough for my system, it's accurate enough. But life or death situations, you can't say that, yeah, my system works 90% correctly, but what if that 10% means that losing a life? Would you still trust that this is accurate enough? That's a hard thing to say, I guess. So this was going to be my final year project at uni, and as you can see, this is a very complex project, and I thought to myself, I wouldn't have time to develop this over 3 months and write a 10,000 word thesis about it, and I thought that maybe I will do a proof of concept. Not a fully disaster response system yet, but just to demonstrate the same workflow over a test case so that we will understand maybe this might be possible in the future for a disaster response system. So what I chose as a test case is mapping London leisure hubs, which I'll again use geotagged social media posts, and then the goal is to show them onto the map as maybe in a clustered way, so that we will locate the people in real time and do a bit of machine learning and sentiment analysis as well, so that we will understand from this data, not only show it, but understand few patterns from it as well. So as data sources, I have two main data sources. The first one is the Foursquare API, which you might ask why she chose Foursquare, why she didn't go for X or Instagram, something much more trend at the moment. But it's because this one was free and I had no budget for my final year project. And how Foursquare works is you can post the venue you're at and maybe some reviews about it and a row category. But that's all the data, basically, the main columns that you will get. And I use some few planning layers from London data stores as well. So for the workflow overview, it has 6 main steps, which I will guide you through. So first, it starts with data collection, which, like I said, I'll get the data from Foursquare API. These are the columns that we will have, and then some London data store layers. I got 4 of them. And I did a little bit of cleaning for what I got from London Data Store using QGIS, but I didn't touch anything about the real-time data because that was the idea in the first place. We need to get that data in a raw way. So I wanted to understand if a machine learning classification would work. So I wanted to get this raw format of data, the venue one, and put them in 6 distinct leisure categories. That's where the machine learning comes in. And I wanted to add the sentiment analysis as well, just to not to point out where they are on the map, but understand what they're thinking, the people. And I integrated the planning layers on top of the map and created an interactive map using Folium library so that we will be able to filter some information and users can interact with the map itself. And after that, I wanted to add some reporting as well for some of the non-technical users, because not everyone is a data scientist and can understand it right away. So the first step, and I would say the main step, is the classification problem. So classification is a classic supervised learning task. And how it works is for these 5 basic steps, you extract few text features from the venue descriptions, and then you represent them because you'll get them as a text, but you need to have them as in a numerical vector format so that your model will understand. And then I needed to train the classifiers and validate those classifiers on a test set, and after that evaluate the performances so that I will understand which classifier is the best one. So how TF and IDF works and what it means is it measures how important a word is in a specific document, and then compare that to how often it appears in all over the data set. So that by using this, you will get some meaningful features for the classification task. And after this step, I first tried SVM, which finds the optimal boundary, the hyperlane, as you can see, between the classes. And I'm not going to go deep into how the classifiers work because I only have 20 minutes today, but so move on to the next. Naive Bayes. So this is a probabilistic model that assumes words that each of the words contributes independently, which isn't always true, but for text classification, it often works surprisingly quite well. So next one is the random forest, and the last one. So how this works is you'll have some decision trees, and then each of the decision tree predicts on the random subset of the samples, and then they do after they all have to predict, they will give like a majority voting. That's how random forests work. And for validation, I use confusion matrices. I got a data set from Kaggle, which was from Foursquare in New York City data set. And I had to train 80% of the data set, and that was the most boring job at all because I had to manually label. I can't remember the exact amount, but I think 5,000 data. I had to look at I'm not really sure if you can see the table, but there are some categories that you might get the data as, for example, for a category, I had dining, and one data might come as a Chinese restaurant, and other might come as a cafe, and another one as a bakery, and they all needed to fall into the dining one. So I had to manually label them. And after that, 20% I used for testing. So how the confusion matrix works is you'll have some true positive, false positive, true negative, and false negatives. And by using simple equation, you'll try to extract the most accurate one. And what you will try to find here is the highest F1 score, which in this case, it was random forest. So in this project, I used random forest. And I added a sentiment analysis as well, like I said. And I'm not going to go deep into this, but basically for every review I got, I assigned them a polarity score from -1 to +1, as you can see some examples down there. And why sentiment matters, why I added this is because it is, yes, it is powerful to maybe get the real-time data and show it on the map, but it will be really useful if we can actually understand what that data means that we see. So that's why I wanted to add sentiment analysis. And then I added the planning layers, which was those 4 layers that I got from London Data Store, and an interactive map using Folium library to engage with the data. So how it works is you'll get a really basic home screen, which you'll have few filters, and you can select your borough, and then you can select your neighborhood, and after that you can select those 6 distinct categories. And then I added the year filter as well, because Postgre only gives me 50 data per request, so I had to add the year as well. So for the year, you can choose either real-time or a specific year if you would like to see other patterns across all the other years. So yeah, this is how it works. And then you'll get some automated reports. This will explain how the system works, and what data you've seen on the map will show up in here as like some venues, and then you will see a distribution of it and the overall sentiment score. So I wanted to, since I cannot run the system at the moment, I wanted to show some pictures of it. So here is one I run on Greenwich, and here is another one I ran for Southwark. And yeah, applications beyond leisure, I think it can be useful for urban planning, which we can understand where people gather, what people, at what times, and in what type of venues, so that we can improve some public spaces. And for retail, it can be used if you're a small business owner and maybe you can't afford nice location planning and understanding, so that you might just wanted to look at if your store is in a busy area or not. And yeah, and also for tourism as well, because especially for me, sometimes I would like to, when I visit a country, I would like to be in the crowd, or sometimes I would like to avoid the crowd. So by using the real-time data, it can be used. So returning to the original vision, what I tried to do is getting a real-time system and real-time geotagged data, and wanted to have it in a disaster response system, but I couldn't. So what I did was, like I explained, having a test case so that to see if the same workflow will apply for a disaster response system later. But the challenge and the bias and the ethics I would like to talk about the disaster response system is it will only represent the people who share online. So what if happens if you don't post? Are we going to miss you? And this is what we need to consider it about. And the noise, of course, there will be irrelevant posts, so that we will need to handle that as well. And lastly, the privacy, because it's personal data, so all these needs to be in a consideration. And for conclusion, what I would like to say is, by personal experience, I saw a problem. I thought about a solution. And as a proof of concept, I did a test case, but my main goal is to try to build this system. And I think that it is actually feasible. As you can see, I think I kind of proved it in a way. But I only graduated last year, and this is my first year in the industry working with geospatial data. And I'm trying to learn as much as possible from my brilliant colleagues at Geolytics, and trying to learn from geospatial data, how we can use it. So I would like to use this platform today as a invitation for collaboration, because I need help. This is a really complex problem to solve, and there's lots of things to consider about, to build. And another thing that I would like to say is, I think if we can all work together and contribute to this and make it open source so that everyone will be able to use this, because it's a general problem that all of the countries will have. And so yeah, all the countries should have an access to it, all the governments, not just countries and governments, literally everyone should have access, because at the end we're talking about saving lives, so it should be an open source. And yeah, so thank you for listening to me, and here is a QR code if you would like to read more in depth about it. It will take you to the publication. And yeah, hope we can connect, hope I can get some guidance, and hope I can get some help. Thank you.
Thank you so much, Asli, and what an amazing project. Let's have a second round of applause, because isn't it fantastic when people latch onto these technology and these ideas through something that they see through their own experience and a real world problem that they want to challenge. So we should be grateful for people like Asli who stand up and do that. I think we've got time for one or two questions, and Dennis is going to get straight in there.
I've seen a project before, and that's exactly the reason why I invited you here, because here we have people from Hot OSM and Map Action, and I really hope that you can talk to them and develop that further, because the right people are here who can help you, and I hope that will happen.
So Dennis has basically underlined what I've just said. There are many people here who can help Asli with this project. It's a really worthy project. So get out and connect, and anyone who can help Asli, come and talk to her. Because I have one final question that I'd like to ask you, is that, and well, it's maybe more of a statement, and it's something that I feel is a common theme through the presentations that we've seen today. Yet again, like Yuchi, you've had to compromise slightly on the data that you've had access to, because you put up the Facebook and the Instagram, and Yuchi put up the Strava logo. And do you agree that, I think it was part of your final statement, that these companies should be opening their data for the greater good?
Exactly.
And it's a mission we should all have, I feel, in our jobs, where we have the opportunity to release and put data out there. We should do it, because look at what these amazing people do with it as a result. Thanks once again, Asli. It's great.